Hello everyone, I want to show you how you can conduct ANOVA, One Way Anova analysis in SPSS. So this is the data you can see in the variable view. There is a gender and then the student's major and also their scores per subject, and also they have a GPA after 3 semesters. So today we will use the variable with the major and then GPA. So in the data view also you can see that is arranged in the top variables, and then you have the scores. So we will use the GPA and the major. So every the letter should be coded as a number in the SPSS. As you know, in the variable view you can see that the major, that is the number now. Number one means computer science, number two, engineering, number three, other sciences. So if this was not determined, you have to put the value 1, 2, 3 to indicate each number means these labels. Okay, so this is done. And now we can conduct the ANOVA test. So analyze and compare means and proportions. So maybe you have only compare means, but that is the same thing. And then you can go to the one-way ANOVA. And here you should put the independent variable, that is a major, is in the factor. And then the GPA should be in the dependent list. Okay. And then now the post hoc, that means that when you will have the significant result, you should know from where it's happening that significance. So normally we choose the Tukey test. That is about when the equal variance was not assumed. So in this test, I will show you when that is assumed. Equal variance is satisfied. You can use the Tukey test. And then options. So you need the descriptive, and then homogeneity of a variance test, and then means plot. Okay, continue, and then okay. So one output is generated, and it is showing that descriptive is about the three measures of the mean and the standard deviation, etc. And then this is the homogeneity of variance. So in ANOVA test and in the t-test, we needed to assure that the homogeneity of variance is accepted. So here, the significance is 0.053, and then this is all are greater than 0.05. So this means that homogeneity is assumed. When that is less than 0.05, homogeneity is not assumed. In the ANOVA table, you can see that the differences from the grand mean, that is significant, is less than 0.001. So this test is significant. This means that one of the three uh, groups, I mean, in a one group of the measure, there is a variable, and the one subject, like computer science or engineering or other sciences, are significantly different from others. But we don't know yet which one is different. And this is the effect size, how much is possible to happen in the real life. That is eta squared, and then you have the value here. This means it is large. Okay, so you will have your table about how you can interpret the eta squared, and then this is the area of the big effect. And the post hoc test means now when you see the ANOVA table is significant, but you don't know where exactly happening, and then you can see in the multiple comparisons. So computer science, engineering, they have the mean difference is this, and the significance is 0.09. So it's not significant. However, computer science and then other science, they have a significant result. So this means that the mean value differences is 0.577. that means it's significant. So in fact, the significance is happening between computer science and then other sciences. Now we can see engineering, computer science, you already saw this. Now engineering and other sciences also is a significant result, and the mean difference is greater than computer science and other sciences. Here is even greater, so 0.80. So this is the way how you can find uh, the significance in the post hoc test. So you can see that in the summary, other sciences, they have both of them the significant result. Okay, so this is about the homogeneous subsets, and you can see that it's only other sciences are in the different subsets. They have a homogeneous subset. This means this one is greatly different from the other one. And finally, this is means plot. So that shows that visually how they are different between the three groups. So the computer science and engineering, they are different, but not very much. However, the other sciences are very different from these two, computer science and engineering. So we can conclude that ANOVA test was significant, and in fact, that happens from the other sciences uh, and the other two similar mean scores of the computer science and engineering. Thank you.